unvibrate your
Hey!
phone. Hey, tell her she needs to unvibrate her phone.
My phone's always on vibrate.
It's literally the big fancy words and they're outlined there in red letters.
All phones on silent.
I know. No, look, it's fine.
All phones
it's
on
always
silent.
on vibrate.
It's the very first one.
It's always on vibrate.
Well, you need to unvibrate it. You need to make it silent.
Although,
just for 2 hours.
Although, really, their default mode should be on vibrate, just because when you lose your phone,
that's
you
my
call
default
it,
mode.
You think, what's the
I always
phone
have it just on vibrate.
I never do, and I lost it this weekend. It took me forever.
Are you planning on losing it in this episode?
No, but like if my mom, texts. Okay, anyway. Yeah, Brandon's here. Look, he made it. I mean, he won't be here for like the next 2 episodes, but
he's not gonna be here for any more episodes.
This is my final episode.
This is Brandon's final episode of the year.
She's like, who's this?
Oh, this is spam. We got spam. We got spam bot.
You don't know that. Paul could be a nice person.
Okay.
Okay. All right.
I mean, they have the word tech in there,
That's
so
true.
they know
That's
some
true.
things we like.
I wonder what Vark is, though.
Vark?
That is hello. And this is like,
see,
hello,
she does
everybody.
text me. Well, Mom, if you text me, I might not know it because my phone's on silent because rules.
I'm going to put my phone
rules.
on vibrate right now just because.
And then it vibrates, and then you're going to think it's mine. You're going to...
Oh, it's the perfect crime.
Except he's going to know it's yours, but still blame me just to give me a hard time.
Yeah, pretty much just how I'll do it.
All right, I guess I'm rocking and rolling this show. So
yeah, you got in the middle chair.
I will let Brandon do the honors for his final 2021 episode of giving me a countdown.
You're so tiny.
Oh God, when I'm in the middle of both of you.
I look like I'm 800 pounds, but you look like you're just so tiny.
Hello, everybody. Welcome to Cosmos with Cosmos.
You're the moonlets of the group.
My name is just Liz.
The moonlets. That's what we're looking for. The moonlets.
All right, give me a countdown to
and
start this bitch
5,
off.
4.
Hey everyone, welcome to another episode of Cosmos with Cosmos. I'm Liz.
I'm Mike.
And I'm Brandon.
And this episode, we're talking the eyes of the universe.
Ooh,
which are telescopes. Telescopes. We're getting ready for James Webb to launch eventually one day. We'll talk about that. And so we're going to talk about the different telescopes, space telescopes that we have, a little history on telescopes, and an all-around good time for hopefully everybody involved. I mean, we'll have a good time.
Looking forward to telescopes.
Oh, I see what you did there.
I guess I can look backwards.
Oh my god. All right. New drinking rule.
I think we need to focus.
Hey.
Any pun is gotta take a drink.
Okay, so in light of that news, we have some rules that go
along
with our show. Of course, any dog barks, take a drink. Lord of the Rings references, take a drink. Star Wars references, take a drink, and any telescope puns.
Telescope
puns.
No. I said puns.
Oh my god, no! That's terrible. It's a terrible idea. You know who you're with.
I know. I'm trying.
That's the only reason I'm here.
I figure she'll do a few. I
do, yeah.
And we take those drinks.
Right, we'll see.
I'm trying to cut instead of 100. We'll cut it down to 25.
Okay, that's reasonable.
That's reasonable.
I'm going to forget all about this rule. Of course, as always, follow us on all the things at Drinking Cosmos, on Twitter, Cosmos with Cosmos, on everything else. And, of course, the piece de la resistance of the show is our drinks.
Oh, yeah.
Can't have a Cosmos with Cosmos without some drinks involved. So I'm going to kick it off with you, Fancy Physics Man. Fancy Punky Physics Man.
It's because I have the longest drink name, right?
Oh yeah, you do have a long drink name. All right, what drink you got?
And then explain.
You know, I thought we were going to be talking about that Black Flag's Damaged was released 40 years ago today.
Today, 40 years ago.
Yeah, I thought that was our topic.
Oh.
I mean, we would just listen really well.
Anyway, I am having the spherical aberration, the spherical bastard of telescopes. Yep.
Nice. What is in that spherical bastard aberration of telescopes?
We have orange juice. We have a little bit of cranberry juice. Mm-hmm. We have vodka, Aperol, triple sec, club soda in there. And instead of an ice ball, we have a cranberry ice ball.
Ooh.
So we're drinking the same thing.
Oh.
Basically, yeah. Cheers.
Yay! Except I wanted to call mine the Eye of God. So that's what I'm calling it. So see, it's a smaller glass. You can see its eyeball real well. See that pupil right there? Eye of God.
Eye of God.
Well, I'm being an individual because that's what Black Flag would want me to do. So I have a different drink.
You
I have the Hydrogen Alpha drink, which is my classic cider and bourbon.
You know what? But our drink looks more like what you'd get from Hydrogen Alpha.
That's true. The red
More.
filter.
Yeah.
The red filter.
Yeah. Mine's like if I had an HF filter, but it broke.
All right, cool. Well, we got our drinks. So I guess let's
I don't know what you want me to...
let's continue on into the meat of the show about telescopes. So we'll first start with a little history on telescopes, a little back for it. Maybe what a telescope is. I don't know how.
It's a tube.
It's a tube.
It's a light bucket.
It's a light bucket.
It's a light bucket.
Its job is to collect light and then show us things we can't normally see.
You know, that's in the episode right there, folks.
That's it. That's all.
Well, let's go back to Hans Lippershey's patent.
Ah, good old Hans.
Oh.
His patent application. He says a telescope is for seeing things far away as if they are nearby.
Oh, well, I guess.
So that's
Hey,
a
to the
telescope.
point.
Yeah, I guess
the
that
point.
is yeah,
Yep.
that's a telescope.
Objects in the mirror may appear closer or farther than they
Than
appear.
they appear. Yeah.
Yep.
Put that on my telescope.
All right. Well, so in 1608,
Uh-huh.
Hans Lippershey from the Netherlands, he creates a telescope.
Okay.
And
Did he call it a telescope?
I don't know if he did
Or
or not.
did he call it?
And did he create the telescope, or was he the first one to attempt to patent it? And there's still some mystery
Well,
around that.
there's a lot of mystery. There's a lot of fucking
Sounds like we
mystery.
need to resolve it.
He was robbed. Or no, the other dude was robbed.
You guys missed my joke. That's okay. We
Oh,
don't need
God,
to drink right now anyway.
what was your drink?
We got to resolve the mystery.
Oh,
Oh,
shit. Yeah,
shit.
big drink,
God.
big drink.
I see. I've already forgotten about this rule for one thing.
Yeah. And to ride this home.
You know what?
That was too high level of a pun
Yeah,
for my
Resolve?
brain.
I even forgot about it. And I came up with it.
I knew this was gonna happen. I knew. Okay.
All right. So we might hit that roll, hit and miss. All right, but anyway, he was the first to patent it. But there's a lot of controversy as to actually who invented the first one. Every country basically in Europe wanted to claim inventing the telescope, but he's the first to patent it. The patent was denied by the Netherlands because of controversy. There were other people who said that they had also invented it, and so the Netherlands said it's ubiquitous at this point, and so
that anyone can make one, so it's just
Anyone
like
can make
it's
one.
not
Easy.
novel. This isn't a
Easy,
novel
yeah.
thing. So
yeah. So
Adam says I think he
denied.
called it sight longer.
This
That sounds like a bad character name in like some weird anime. This is such longer.
He sees real
It
far.
really does. what a special power, though.
I mean,
Really?
Yeah, that's a
it's kind of
superhero
cool
power.
to be able to, you know.
Yeah, like you just like Jordy, where you can just kind of.
Yeah, and you can switch, and
you
you can switch wavelengths too. Jordy can switch
Yeah, yeah.
wavelengths, so I mean, he can see in the full
Yeah, that comes.
electromagnetic spectrum.
Well, the thing.
I was gonna go off on the Star Trek episode when he's actually trapped on the planet with the Borg, and they have to use each other to survive because Jordy lost his glasses and he needs somebody else to see. It's a whole thing.
Why don't I remember this episode?
I'm sorry. It wasn't.
No.
Definitely wasn't. Was it the Borg? Maybe the
I don't
Borg.
remember it being the
It wasn't a
Borg.
Romulan.
It was the Romulan.
It was a Romulan.
Okay.
The Borg aren't gonna
No,
work
no,
together with anybody.
Because he develops another relationship with the Borg later on when the Borg tries
Hugh.
to. Huey, yeah.
Oh,
Yeah,
Hugh!
but he loses his glasses with the
All right.
Romulan.
Yeah,
We
that's the
need
Romulan.
a-
That's right.
No, we're gonna talk about
We
this.
need to focus.
I've already used
God damn
focus,
it.
so I can't. We've already used it. No
Take-
reusing. If it's a reuse
Take
of
a
a
drink.
pun.
No, he said focus.
But I said that earlier.
Oh, we need to clear this up.
I made that pun earlier. That's
Some
what.
aberrations
That's
on
what
this.
started this. Oh, that's one aberration.
Okay, we need to get on track here. Come on, host, bring us back in.
In her defense, she did try.
Mm-hmm.
All right. Anyway, so interestingly enough, his failed patent was put in a Dutch diplomatic communique. And people found out about it.
Why?
I don't know. It didn't say.
What else is he going to do in 1600s Europe?
But it was kind of an afterthought in this communique. And
by the way, this dude says he invented a telescope.
Yeah, by the way, we have this eyeglass maker.
He's calling it the sight longer. I don't know if that name's going to stick,
It's going to change our perception of science forever. Don't worry about it.
He was writing names down on his iPad, sight longer being one of them, yeah. But... that is now the name of this episode, Sight Longer.
Sight Longer. Thank you, Adam.
Yeah. But anyway, so a bunch of people found out about it. In the last episode, I think we talked about Thomas Harriot.
Yes.
Do you remember?
I don't know. I don't remember what happened.
He looked at the moon and drew it.
Yeah.
Oh yes. Okay. Many years his drawings lasted the most.
What are these words?
I was just gonna let her go. We would eventually get there.
I'm trying to find a word, and
we would eventually get there.
Accurate.
Yeah.
That's the word I was looking for.
Okay. So among the people were Thomas Harriot, who did in 1609, July of 1609, did the most accurate drawings of the moon at the time, and it lasted for decades.
Yeah. See. Okay.
Yeah, but also a little guy, you may not have heard of him.
Okay.
I'm pretty sure you haven't. There's an obscure astronomer named Galileo Galilei.
Oh, this motherfucker. His name
Did you really
rings
think
a bell.
I was going to say some really obscure...
Yeah, I thought you were going to say like that guy.
Oh,
and
no,
then I was
that Newton
and
guy.
I was going to be like, oh.
Oh, no, she pointed to Mikhail.
No, I didn't.
Did.
No, anyway. Galileo. Just an obscure astronomer who really didn't contribute a whole lot to the field or anything.
But anyway, he improved on Lippershey's design.
Yeah.
So he made a series of telescopes, and his first design had a power of 3, so things were 3 times the size, which interestingly was also Lippershey's power on his telescope as well.
I also want to point out, so when we think of telescopes today, we think of something like the Hubble or James Webb, these big giant mirrors that capture all this light, but in this case they weren't mirrors, they were 2 individual lenses.
Glass.
Glass. 2 small pieces of glass, yes. That were a certain distance away from each other that could magnify the image. So not the mirror, just those lenses.
And they were using convex lenses. So a lens can be like this, which is convex, or it can be like this.
Oh.
And so
for those of you on the podcast, imagine like a stereotypical diamond as one shape. And then going inwards and 2 slants with you.
Yeah, except it's curved, and so when it is that diamond shape, which is not really diamond shape.
I know,
but when it is when the glass bows out, it's convex. When it bows in, it caves in, so it's concave.
Yeah.
And so Lippershey,
vocab words of the show, everyone.
Lippershey used 2 convex lenses, one for the main lens, and then one convex lens at the eyepiece. That's important because we're going to get back to that in a minute.
All right, take note.
So anyway, Galileo, he uses the convex design, so 2 convex lenses. His third telescope had a power of 23, and that's
a big jump.
That is a big jump.
Wow.
It went from 3 to 8 to 23.
Okay, still,
Yeah, and so from that, he was able to, discover moons of Jupiter.
How long was this telescope?
It was 40 inches, 1 meter.
Oh, so a meter.
Oh, okay. That's not too long.
No. Okay. But it is 2 small pieces of glass.
Tiny little thing.
Yeah. I think the main lens for that power of 23 was 35 millimeters, so that's 3.5 centimeters, which is a little more than an inch. We'll say 1.5 inches.
Wow.
I have no spatial awareness, so what you just said was just like numbers and words.
You don't know what an inch looks like?
I can't visualize it. I need like a ruler. I can't visualize length.
These pointy knuckles, that's about 1 inch. That's about 1 inch, yeah.
All right.
Man, this podcast is just...
Look, I got a pretty good photographic memory, but visualizing spatial things, I can't.
Do you really have a good photographic memory?
Yeah.
What was I wearing yesterday?
I wasn't paying attention to things I pay attention to. Remember the thing I was describing something the other day to you? I forget what it was.
You're going to be tested.
Remember this.
This is going to be a test.
Remember these fingers are holding up. Okay, we should get back on track.
You're in charge.
Continue.
Wow. Okay. Well, Kepler comes up next.
Caps!
Yeah, he actually improves Galileo's telescope.
Oh my,
but he does it in theory.
Oh,
he doesn't actually do it.
Yeah, what a lazy bastard.
He's a pen and paper kind of guy.
Yeah, he's definitely pen and paper. He was like, why don't we use convex lenses? So
the bow and
caving in.
Yeah, caving in.
Yeah. Oh, I'm sorry. No, it was concave.
There we go.
He was using concave. He was using concave lenses. It wasn't, that was in 1611. It wasn't until 1630 that Christoph Scheiner, had to have been German.
I was just thinking that. Christoph Scheiner!
He was actually the first to construct and use Kepler's design.
Oh, okay.
Yeah, so it took a while. Kepler's like, I don't care anymore.
I mean, yeah, I made it better, but someone else has to physically make it.
Yeah.
I've thought of it better.
Yeah.
That's what he did. He thought it better.
Fast forward to 1668. One Mr. Isaac Newton, the inventor of the fig Newton.
That's like 301 years before you were born.
Very good with the math, by the way.
I secretly counted it on my fingers right under here. I went 7, 8, 9.
Oh my goodness.
+1 for the 69.
What did Newton do?
Nothing.
Okay.
Like I said, he invented the fig Newton.
It's true.
That's why it's named after him.
Oh, okay. Those are yummy.
Yeah. So he was like, why don't we use mirrors instead?
Hey guys, I got an idea.
Except he wasn't talking to anyone, because God forbid he talked to anyone. He was talking to himself.
You know what's going to be like less difficult to make? Mirrors.
Well, he was trying to get rid of that. I called my drink spherical aberration. Mm-hmm. That's an actual telescope issue, where if you use lenses, if you use just regular convex lenses, what happens is you'll get this like little rainbow.
Oh, is it like the blue and the yellow? You kind of see around the edges or something.
That's an aberration, which is and it has to do with light going in. Like blue light gets bent a different amount than red light, and it doesn't all focus at the same point. And,
so Newton's like, hold my beer. I'm gonna fix this issue. Mirrors.
Probably hold my porter. I
think he was just looking at himself in one, and he was like, "Oh, where could this be most utilized?"
Side note, I would love to see a tipsy Newton. I would just love to see what his communication would be like. Because he's just a weird guy in general.
Okay, I'm like, do you know how he just like normally communicates?
No, poorly. He was a very poor communicator. Okay. He was very antisocial in general. But I would love to see him kind of open up a little bit. Say, hey guys, this is what I'm working on.
Sounds like he'll turn into me.
Anyway, he builds a telescope with
mirrors.
And by the way, those telescopes that have the glass lenses. Mm-hmm. Those are called refracting telescopes. Yes. They bend light.
And mirrors
reflect light.
There we go.
And they're reflectors. Those are reflecting telescopes. Anyway, he builds the first one. He designs what's called the Newtonian telescope, which I think Brandon has, which has the mirror at the bottom. The light goes up to the top and off to the side, and that's where your eyepiece is.
Yeah, that's what we have too.
And so it makes it a little bit easier for people to stand up and
look through it instead of like trying to be at the bottom of it.
Yeah. And the mirrors get rid of that aberration. A couple years later, 4 years later, my favorite telescope, Schmidt-Cassegrain telescope.
Yeah, that's what I was pointing at. I was pointing at that, and I was going to be like, oh, Schmidt-Cassegrain.
Yeah, Laurent Cassegrain comes up with a design. It's a reflecting telescope, kind of like Newton's, except the eyepiece is down at the bottom. And so the light comes in, hits that mirror, and it does go up to the top of the telescope, but instead of exiting the telescope at the top, it comes right back down at the bottom.
All right.
We used to use those all the time in Phoenix.
Oh, yeah, the eyepiece was at the bottom, huh?
Yep. Fast forward exactly 100 years. Mikhail Lomonosov, he's Russian.
Lomonosov.
Luminoso.
Miguel Luminoso. I drink vodka.
He actually designed a telescope that was like Newton's telescope, except he the primary mirror at the bottom was tipped over 4 degrees, and so you could be at the end of the tube and look and see what the telescope is seeing. But he didn't publish it. Kind of like Thomas Harriot.
You gotta screenshot or it didn't happen, people.
Yeah, so he didn't publish it. In fact, it wasn't published until 1827. So many years.
Wow, 18?
Many years later. And then, but at that point, it's already known as the Herschelian telescope after one William Herschel, because he had come up with the same design.
I've never heard of a Herschelian telescope before.
But he came up with it after Michael did. But he gets the credit because, William, he took
a screenshot.
He took the screenshot.
And since the Herschels are, Brandon's favorite people.
Oh my God, they're my favorite fucking astronomers.
All right, I'm gonna let you do the shout out, man.
So William and Caroline Herschel were a brother and sister duo who revolutionized what we saw in the sky. They were the first people to make a map of the entire night sky using these instruments, telescopes. And they actually became amateur professional telescope makers. Because down in the basement, they would actually make the mirrors themselves and refine it exactly how they want. So they got bigger and bigger and bigger mirrors, and these became huge contraptions that were, given funds by the royal court, I guess we would say. Until it became so big and so expensive that the guys were like, no, you can't do this anymore. So he actually had to downgrade himself, because it was so difficult to make, number one. And number two, it's so difficult to align to the stars and make, these drawings. Because they don't
you gotta move it.
Yeah, they can't scan the sky and just move it with Earth's rotation. You have to physically move it yourself, which is difficult to do. So when this thing is 10, 15, 20 meters long, it's impossible.
Wow, so they're just a little ahead of the technology available to make those telescopes.
Yeah, but he and Caroline have the first map, we can call it, of the Milky Way galaxy. They had such great images with the telescopes, and they drew what they thought at the time as the entire universe. But it was basically just the band of the Milky Way.
Yeah.
And it's a really cool image to see if you want to go look at that Caroline William Herschel map of the universe.
That's cool.
It is really neat.
Man, remember when we had to hand draw everything?
No.
What was the look?
I always have MS Paint. I don't know what you're talking about.
What was the faraway look?
Just into the past. Just remember the olden days, because we're gonna transition into fucking shit we have today.
And Karen just brought up the bigger the better, which for telescopes is
what you want. Yeah, the bigger the light bucket, the more light you can collect, the more you can see.
Yeah, so the wider it is, the more light. The longer it is, the longer the focal length, and so you get better resolution. No drinking, because that actually
is though
it's legit. Yeah.
But now we don't need to draw things.
No, we don't. We definitely don't.
And we don't have to worry a whole lot about various atmospheric effects and weather on the planet, because now we got telescopes in motherfucking space.
But why would we want to put telescopes in space?
Because it looks fucking cool.
Because what I just said, weather and our atmosphere mess shit up.
Yeah, but what if it's a clear day?
Yeah, I mean, first of all, it's cool.
Because it's daytime and you can't look at the space in daytime.
What if it's a clear night? The atmosphere. Okay, so...
Yeah, I mean, it's fine.
I had a whole bit about putting sharks in space, but we're going to let that go now.
All right, the reason why you would want to put a telescope into space above the Earth's atmosphere is because the atmosphere is a problem.
That's what I was just saying.
But you didn't say why. The atmosphere is turbulent.
Twinkle, twinkle, little star.
Yeah, exactly. The same thing that makes the stars twinkle kind of messes up your telescope.
It's like when you're trying to take a picture of like your pet, and then they move, like they're in the cutest pose for 5 minutes, and then as soon as you take a picture, they like move a little bit, and you're like,
and you get a little blur.
You're like, God damn it!
But it's constantly moving.
Yeah. So there's a reason why they put telescopes on top of mountains.
Where it's colder.
Where it's
as
colder.
Well, thinner.
You're above a lot of the atmosphere.
Mm-hmm.
Also, if you can put it near kind of like either at a desert location or paradoxically in the middle of the ocean, like with the telescopes on top of Mauna Kea.
Okay, I was like in the middle of the ocean. What, like on a barge? I wasn't thinking an island.
Yeah. So so you have more stable atmosphere. Your images are clearer.
Yeah.
But the clearest place to go is actually above that atmosphere, and that's what they do with like Hubble, Spitzer, and all this kind of
with
stuff.
All the various, which is why they're called space telescopes.
Space telescopes, exactly. But also, the atmosphere, thankfully for us, filters out a lot of like gamma rays and X-rays. And
so we can't really see those if we are trying to use ground-based telescopes.
Right, and so that's why some of our modern observatories really the only place that you can put a gamma ray telescope observatory is up in space.
Some would say they're great.
Okay, Liz. They're great observatories.
Yeah, and recently Hawaii has had blizzard warnings.
They did.
Which is the craziest shit.
The other day, there were only 2 blizzard warnings in the entire country. They were in Alaska and in top Mauna Kea.
I didn't know that.
Yeah.
It's terrifying.
That's the world we live in, everybody. All right, so space telescopes.
Let's
talk about some of them. So we have different types of space telescopes up there that utilize different wavelengths of light based on the things they want to study. So first, we're going to talk about a couple gamma ray telescopes, which gamma rays.
What's a gamma ray?
It sounds super cool.
It's
a high energy light that will kill you real fast.
Oh yeah, well, yeah, or real slow with cancer.
Oh yeah, depending on
either way
your exposure. I suppose.
Either way, it's gonna kill you.
And so by the way, the telescopes that we're focusing on are. At least that I've put in our notes here, are NASA telescopes that are currently active.
That's fair.
Okay, so because I mean, really, there's so many and so many good past ones that we could go all day, as we always do. Gamma rays, grandma. All right. So these gamma ray telescopes, they're gonna collect and measure high energy gamma rays from space stuff, from astrophysical objects.
From all over the universe.
So one of them that we have up there is the Neil Gehrels. I don't know how to pronounce that. I'm just going to go with Gehrels. Gerbils. Swift.
No, not.
Don't say that.
No, don't say that one.
Oh, no, that's Goebbels.
Well, don't say.
Neil Gehrels. Swift Observatory, the NGSO.
There we go.
How about we do that? Well, there's no acronym for it, though, actually. I guess maybe just Swift Observatory.
You just made one.
So it's like a 3-telescope-based observatory. So it doesn't just utilize, it's not just a gamma ray telescope, but it also has UV invisible light capabilities as well to it. Basically, its job is to study gamma ray bursts, or GRBs.
And they're fast ones too, fast GRBs.
Which is probably where the Swift name comes in, but I'm going to talk about that in a second. And then monitoring the afterglow in X-ray and then UV invisible light, to basically kind of measure, just kind of what happens throughout all those processes. I got it. I'm fine.
Yeah, but now all the audience knows that you're low on your drink too.
That's okay. It's a small glass. All right. So the name SWIFT is not just like a mission-related acronym, which I thought was interesting because NASA loves mission-related
they love
acronyms. They're all about mission-related acronyms. But rather a reference to the instrument's rapid slew capability that allows it to move fast so it can capture shit. So it's SWIFT. And also after the nimble swift bird, a bird of the same name.
I didn't. Really?
Yeah.
There's a bird called
That seems
Swift?
tangential.
Yeah.
Like-
Look, it was on
Like
Wikipedia,
they
so
were
it's
just trying to tie
100%
it
legit.
in. You know, it's become cool if you name it after this bird. It has the same name.
Swift bird. I mean, they could have called it like Rapid Slew. You know, it would have been like the RSGT, Rapid Slew Gamma Telescope or some bullshit.
Sure.
All right, anyway.
Right.
All right, so it has the 3 instruments on it just
They could
because.
have called it Quick.
Yeah, quick.
They could have called it Fleet.
Yeah. But they were like Swift like the bird.
Yeah. There's a lot of words in the thesaurus that we could attribute
This is
to this.
true. Yes.
All right, cool.
Okay.
All right.
Anyway, so it's 3 instruments, and I kind of wanted to bring them up just because the first one is called the Burst Alert Telescope, or BAT.
There's your acronym.
So the BAT detects GRB events and computes the coordinates in.
Okay. All right.
Yeah, so that's what it does. It basically finds them, and then you have the X-ray telescope, and then the ultraviolet optical telescope, UVOT, UVOT. And they then will take the pictures. Are you looking at this one?
No, I was actually looking up the difference between an acronym and initialism, but we'll talk about that in the Hangover.
Jeez. All right.
You mean the Hangout, right?
All right.
Yeah, thank you.
So its mission, determine the origin of GRBs. There seems to be at least 2 types of GRBs, apparently, that astronomers have discovered, but they need more data to kind of explain these different types. To use the GRBs to expand our understanding of the young universe.
Did we actually say what GRBs are?
Yeah, gamma ray bursts.
Oh, okay. All right. Cool.
We didn't explain what a gamma ray burst was, though.
Well, that's grandmas
burst of gamma
sometimes
rays.
do that.
Oh, yeah.
It's a burst of gamma rays.
Yeah, you gotta watch those You gotta watch those gammas. And then to just kind of serve as like a general purpose gamma X-ray optical telescope to be used by researchers in their scientific endeavors, quests.
Things.
Oh, that is one.
Well done, Liz.
Where are we going?
Space, low Earth orbit.
All right, and then we have the Fermi Gamma Ray
That
Telescope.
sounds like a paradox.
Named after the Fermi guy that Mike likes because of those small particle physics.
I like them all. I like all those guys.
And so the Fermi Gamma Ray Telescope, which was apparently going to be called the Gamma Ray Large Area Space Telescope.
That's not as fun.
Or GLAST.
Boo. Okay, grass. Okay.
Glassed.
Okay.
So its main instrument is a large area telescope, which they're going to use to mainly perform like all sky surveys.
Cool.
Which is cool, and like studying, like galactic nuclei and pulsars and
Pulsars.
Pulsars.
No, studies of pulsars.
Just these high energy sources as well as dark matter. And its major discoveries came when it detected a pulsar in the CTA1 supernova
Cool.
remnant.
That's cool.
Beautiful name, CTA.
CTA1.
Can you say it in like the right voice, Liz? There's the right
No,
voice.
that's his job.
I know, but you're
I'm
you're
not
doing
saying
this.
it in the right voice.
Nope. I'm not gonna do
Fine.
it. CTA1 supernova. Because I'm so tiny.
What the hell is that voice?
That's my tiny voice. And it appeared to emit radiation in gamma ray bands only, which was the first of its kind ever detected.
Oh wow.
Which
Okay.
is pretty cool. And this new pulsar sweeps the Earth every 316.86 milliseconds and is 4,600 light years away.
That's so insane.
Is there? Did they have
You can't even.
That's
Do they know why it was only in gamma rays?
I just got just a snippet of what. No, I don't have further
Okay,
explanation.
that's all you have to say.
No. And then another of its discovery is the Fermi bubbles, the Milky Way's Fermi bubbles. So
cool.
that two gamma ray and X-ray emitting bubbles were detected around the Earth's and solar system's galaxy and the Milky Way.
Oh, okay. But not around the Earth. It's
no,
actually,
I'm sorry. I shouldn't.
Yeah, wait a minute.
I was about to say, I think this is black hole related.
No. So they're called the Fermi bubbles.
Yeah, these are black hole related, though.
Yeah, and they extend 25,000 light years distant above and below the galactic center.
Yeah.
So
another reason why black holes are cool.
So the Fermi Gamma Ray Telescope detected those for the first time.
Neat.
Which is
it's
awesome.
Fermi bubbles.
Fermi bubbles. Our galaxy's blowing bubbles.
Oh yeah. You know, I never actually kind of thought of it that way.
That's how it sounds. There's no sound in space, Brandon.
Actually, it's a black hole that's blowing bubbles.
That's true, yeah. It's just having a grand old party in the center of the
fucking
galaxy.
bubbles.
It's just got to entertain itself somehow when it's not, chomping.
Well, really, it's like the accretion disk of the black hole, right?
No, it's well, sort of.
Yeah.
I mean, because
take it away, fancy physics man.
Well, the accretion disk helps create this magnetic field,
right?
And so most of the material in the accretion disk falls into the black hole, but some of it actually gets caught up into those magnetic fields that point above and below the black hole, and that is what's creating those.
And so the black
bubbles.
hole's like bubbling over.
Yeah, the accretion disk is bubbling over. Yeah.
I love it. Okay, cool. All right, so next type of space telescope we have are X-rays.
Do it, Mike. We all made X's with our arms.
X-Force X-rays.
Did you guys practice this?
No, we
No.
didn't. No, but it does seem just like the natural thing to do.
X.
All right. The first one is a popular one where I'm sure we're familiar with it. You may have heard it yourselves, listeners at home, and that is the Chandra X-ray Observatory. I knew you were going to do that. So it is sensitive to X-ray sources. I know.
Surprise!
100 times fainter than any previous X-ray telescope.
Oh, cool.
So it's the most sensitive. Yeah, it's like a little Jackie man, a little Jackie dog. It's just so
like
sensitive.
Leia. It's Leia. Leia is
sensitive.
100 times sensitive. More
that's
sensitive
true.
than Jack or anybody else.
And that's because it has a super high angular resolution of its mirrors.
Oh, of course.
Naturally, because that's how telescopes work. And it's one of the great observatories.
What does that mean?
You're loving that.
What does that mean, one of the great observatories?
Well, the great observatories are the pioneering telescopes that, among the family of great observatories, are the Hubble Space Telescope, the Compton Gamma Ray Observatory, which I've never heard of, so that's fine, and the Spitzer.
Oh, yeah.
Spitzer Space Telescope.
Yeah, the 4 great observatories.
And so
Do we need to make that 5 now?
Well, I'm not sure if that was just a generation of telescopes. They all came within a really short time of each other.
Okay, so maybe it's
so
just
maybe
a
it's
generation.
like a generation of telescopes that came out.
It's the greatest generation.
Well, that's coming up. Hopefully.
Yeah.
All right. Some discoveries of Chandra. There was a ton. There were the whole list, a long list of discoveries, so I narrowed it down to still kind of a long. I can't rap. Look at me.
I don't see color.
Okay. All right. So it took the first light image of supernova remnant Cassiopeia A.
Okay.
Which is pretty cool. It's a really cool image. So Google it. And it gave basically astronomers the first glimpse of the center, which is either like a pulsar or a black hole.
Oh, cool.
Which is neat. And then for the Crab Nebula, which is another supernova remnant, it showed never before seen ring around the central pulsar and jets that had only been partially seen by earlier telescopes coming from it.
Yeah, and didn't it show it like pulsing?
Yeah. I was going to bring it up because Chandra's been up there for more than a couple of years. It's been able to see objects for many years at a time, and so when an object like a supernova is expanding, you can actually see that expansion through time.
And then astronomers can measure it and calculate actually how fast that gas is expanding.
Yeah. And to see that like in picture form, it's just mind-blowing.
It's really cool. Okay, so then it also had the first X-ray emission that was seen from the supermassive black hole that we know fondly as Sagittarius A star at the center of our Milky Way galaxy.
Yep.
It's our home
That's
black
ours.
hole.
That's ours. It's the one that made the little Fermi bubbles.
Look there, and that black spot. That's ours. That's it.
That's nothingness and
it's
everything. All
nothing
at
that will
once.
ever be.
It also showed for the first time the shadow of a small galaxy as it was being cannibalized by a larger galaxy in what is the best scientific term ever, galactic cannibalism.
I say some spaghettification.
Well, you know what's funny? If you look at like the tadpole galaxies, they kind of get stretched out by their own gravity. So it's like the galactic cannibalism is spaghettifying the galaxy.
Oh, well done.
2 in 1.
Well done.
2 in 1. I like that.
Also, I want to point out how cool it is of seeing the shadow of a galaxy.
Yeah, the shadow of
That's
a galaxy.
cool.
Yeah, I haven't seen this picture. I'll see it.
I know. I gotta look
That's
this
my
picture up.
new metal rock band. Is
Shadow of a
Shadow of a
galaxy.
Galaxy.
Galaxy Shadow.
Galaxy shadow.
I don't know if that's a good
Shadow.
one, but okay.
What's this new metal with the NU?
Oh,
It will
no,
be
fuck
up
that.
to you.
Fuck that. No.
What's the element on the periodic table that's in you? Is there one?
Nuon. No.
I don't
New
know.
one.
if there
I know. I
is.
was making shit up. I don't know the periodic table. I know hydrogen is up in this top corner over here.
And Einsteinium
And
somewhere down
helium
below.
is maybe in this corner, or they're
Helium,
reversed.
yeah.
I don't know.
Hydrogen, helium.
Yeah, so they're there,
Hydrogen, helium,
and then it's just
lithium.
a pattern of squares below it.
With letters.
Yeah. All right. Okay. Three more. For Chandra, nearly all stars on the main sequence are X-ray emitters.
Oh, cool.
A large halo of hot gas was found surrounding the Milky Way.
Okay.
So, it might be lactose intolerant.
Because it's the Milky Way. Yeah. She's taking a well-earned drink.
Oh, God.
Hubble's constant, measured to be 76.9 kilometers per second /MPC. I don't know what the last one is.
Megaparsecs per
Okay.
megaparsec. It's basically, you're talking about the expansion rate of the universe.
All right, yeah.
basically.
So it measured that. It did that thing. And lastly, in 2006, Chandra found strong evidence that dark matter exists by observing supercluster collision.
Oh, cool.
Cool.
That's cool.
And that's just like
That's
a
just the
few.
highlights.
That's just some
Just
of
the
them. It's
like,
done.
It's like a Tuesday.
It's done so many other things.
So it should get a Nobel Prize.
It should. Well, actually, it's named after a Nobel Prize winning
Oh, Compton?
Indian
Wait a minute, who is
American
it?
astrophysicist
Chandra, yeah.
Subram
Chandra.
Chandra.
Well done.
Yeah. All right. So another X-ray telescope, which has. Now this is your new metal telescope because it's New Star, spelled N-U star. Thank you for refilling my drink. And not by the microphone because Mike hates that, even though I love the sound of a drink pouring in a microphone.
Oh, it's a good sound.
Yeah.
It's a good sound. I'm not saying it's not a good sound. I enjoy the sound.
Anyway, so New Star, it uses a conical approximation.
Conical. New word.
Is it conical?
Conical.
Mike went well actually on you.
That's like when I said, when we were reading Jack Kerouac, and I said, like...
Kerouac.
Kerouac? Yeah, what'd I say?
Kerouac.
And it was the type of jalopy.
Yeah.
And you
What did you call it?
Did I call it a jalopy?
A jalopy.
I said jalopy, and you were like, jalopy? And I was like, oh, is it not jalopy?
Because it's Jalopy Cats come out tonight. That's a
Calico?
whole nother thing. Don't worry about that.
All right, so conical?
Conical. Yeah.
Conical, because I guess there's no E
It's
in it.
it's different shapes. It's the shapes that you can make with a cone.
Okay, yeah, and
Conical.
I guess similar to whatever a Walter telescope is.
A what?
Walter.
Okay, sure.
To focus high energy X-rays. So it's looking at high energy X-rays. So when the electromagnetic spectrum is like not all gamma rays and X-rays and microwaves, they're all the same exact energies.
You
they
know
have
what
an
else is-
energy kind of
It's like purple.
width.
Purple
like
is on that
purple.
spectrum.
Anyway.
Your mom says that she's failed you.
I don't...
That's pretty good.
I mean... You could read it either way. I guess it doesn't have an E in it, so...
No.
All right. This is what I get for not reading a lot, I guess. All right, anyway. So its primary scientific goals are to conduct deep space survey for black holes 1 billion times more massive than the sun. 1 billion times
I can't even
more
imagine.
massive.
I know, right? It makes your head
than the
explode.
sun.
It's just,
Unfathomable. The sun itself is big enough and massive enough.
You can fit 1 million Earths inside the sun.
that's just size-wise.
That's a size.
It's not even mass.
That's not mass. Yeah, that's not mass.
Even mass.
God.
And so, yeah, it's just hard to think that there's that much mass.
Anywhere.
I know, right? The sun's responsible for keeping planets in orbit.
Yeah.
All this kind of shit going on.
You want a black hole
Nuclear
that's-
fusion.
And it's a speck of light.
Yeah.
Against the darkness.
It's just an average speck of light against the darkness,
Yeah.
like you said. But then there's this black hole 1 billion times that mass. And all that mass in one spot?
It's as if the sun's like an Aes Sedai and the black hole is a dragon reborn.
That's a real niche. That's a real niche
not anymore. It's on
reference, is it?
Amazon. I can make these references now. People go, oh, hey, he's watching the show. See? I can do this now.
Okay.
Wheel of Time,
Wheel of Time
everybody.
reference. That was a Wheel of Time
Wheel of
reference.
Time.
For those
Are we
who-
going to have to add that to the drinking rules now?
No, we don't need to
I
add that.
mean-
No. It's fine. All right, so that's not all. It's going to investigate how particles are accelerated to very high energy in active galaxies.
Okay.
And to understand how elements are created in the explosions of massive stars.
This is X-rays, right?
This is X-rays.
Yeah, so, yeah.
Yeah.
When you accelerate things to really fast speeds like that
Yeah.
and move it in a circle like an accretion disk, you're going to get X-rays.
Yeah.
It is the death scream. X-rays are the death scream of things falling into a black hole.
Oh,
Nice,
Death
nice.
Scream.
Mm-hmm.
Damn, I should name my drink the Death Scream.
It's not too late.
That actually...
That's
a
a
good,
really
that's
good-
a band name right there.
Death Scream?
Death Scream.
That actually is a good metal name. That's
like
that's
that.
a good metal name.
Yeah. Don't look at me.
Anyway. All right.
And don't even put it as new metal. That's like regular metal.
Yeah.
I don't even know what new metal is. I just thought it would fit.
Disturbed. Technically Slipknot, even though I do like Slipknot. All right. All right. Any metal that came out in like 2000 to 2000 and whenever metal stopped being fun again, or in the
It's
mainstream.
like beryllium.
New metal
What
is
is that? What? No.
beryllium.
I know it's not a metal.
God. Oh.
'Cause that's not real metal. There we go.
Well,
Okay.
anything that's
Okay.
not hydrogen
That's
and helium is
true.
metal.
All right,
That's
all right.
true.
Anyway, major discoveries of New Star. It measured the spin rate of the supermassive black hole at the center of galaxy NGC 1365.
Nice.
That goes along with your thesis paper you did, right? You did measuring a spin rate of a black hole or something. You did something to do with spinning black holes for your thesis, right?
Liz.
I did. Yeah. Oh God, what was it? God, it was so.
It's under your bed, right? It's under our bed.
Yeah, it was 20 years ago.
His thesis.
And, yeah.
Yes, you worked on it. Yeah, mine.
I do black holes.
You did something with spin.
Yeah, well, it's one of the fundamental properties of a black hole.
Yeah.
And I don't think it had to do with the spin of the black hole.
No.
Yeah, you can only with black holes that you can only measure its gravity, its charge, and its spin. Charge is going to disappear really quickly because if you have a charged particle. You have a charged black hole that's negatively charged. It's gonna attract all these protons, and so it's gonna quickly lose that charge.
Oh.
But what it does have is gravity, but it has spin, and so when you have a spinning black hole, now spinning black holes are real black holes. Schwarzschild black holes, no, it's an idealized. Those are idealized black holes that don't have any spin, but real black holes have spin in them. And what happens is you actually get 2 event horizons with a spinning black hole. Yep. 2 event horizons. And in between those 2 event horizons, you have what's called the ergosphere. And you can dump your trash into that ergosphere and get that can be your energy supply So if you had a space station orbiting a black hole, a spinning black hole, what you do is you put your trash into a trash can and you send it out, and you drop your trash into the ergosphere, and your trash can comes back with more energy than it left. And you can get that energy, and if you're able to get that energy somehow, it gives your space station energy that you could use to power your computers.
But Mike, you said this is between two event horizons. So how can you get past one event horizon and get energy out from that event horizon when you can't, by definition, come back out of it?
Right. Well, the trash can does not actually go. All right. So the.
Oh boy. Oh boy.
All right. So your inner event horizon is that typical event horizon that we call the Schwarzschild horizon.
Okay.
And that is the horizon in which if you pass,
from which there's no return.
There's no return. However, that second outer event horizon.
So this is the first one?
Yes, if you're falling into it, this is the first event. Okay. The first event horizon is the one where you can still leave it.
Oh.
But the second event horizon.
Point of no return?
Yeah. Is the point of no return.
Oh.
So why call it the event horizon if you can.
That actually is a good question.
You guys ever heard of second event
what
horizons?
It is? Okay, so.
What about third event horizons?
What. Let's say that they. What did you say?
What about third event horizons?
I'm actually really interested.
Afternoon event horizon.
I feel like we should save this for table for the Hangover.
No!
I know you're so excited. You're so excited.
We still have to talk about the Hubble and James Webb Decadal survey.
We have like an X-ray. We got multiple light.
We got like an hour left of this.
Look, I don't.
All right.
I don't have a lot to contribute.
You're contributing a lot. You're all our knowledge.
It's true.
I mean, really, what are we here for? Just puns
I'm here to look good.
And all right. So we will come back to getting trash back from a double event horizon black hole, which sounds terrifying and amazing at the same time. All right. Moving on. New star.
Okay, so.
We have X-rays. We had X-rays. All right, we've had gamma rays. Moving on to a light that we can see.
Purple.
Visible.
Oh, okay. All right.
Visible light. And starting us off with visible light is not the one that starts us off in the notes, because really that'll be second because it's the best one. But starting us off is the Visible Light Space Telescope.
I love how you say that as if Brandon and I are actually reading this, but also that the people out there actually even know.
I know. I give too much information through my brain. The Transiting Exoplanet Survey Satellite, a.k.a. TESS.
I saw that launch.
Oh, you saw it launch?
Yeah, I went to the after party, too.
Oh, God, this motherfucker.
It was really cool.
I would love to go to an after party.
Oh, a space launch after party?
Oh, I know.
Are they wild?
Well, I kind of got to the tail end because I was kind of going in on SpaceX's party, and I wasn't a SpaceX person. So I was like, behind enemy lines.
Oh, yeah.
I actually had a lot of nerdy conversations. It was great.
Oh, my gosh. I
talked to Sophia people,
with the rocket, the
Yeah, that was just kind of canceled again for like the 20th time. Yeah, so I talked to those guys for like an hour. It was great.
That's awesome. Okay,
Sophia's not this.
No?
No, Sophia's the infrared telescope, right?
Yeah, that goes up and just...
Oh, okay.
Are you thinking of the Vomit Comet?
I'm thinking the Vomit Comet.
Yeah. Oh, yeah, she's doing this roller coaster movement, and it confused me for a second, yeah.
All right. Well, Tess, that you saw launch, she's doing well, in case you were wondering. So she is studying exoplanets out there, part of the Explorers program, and it's using the transit method. So when an exoplanet passes in front of its star, that light dims, and so they measure
you can measure that light curve.
Like a
light
deer
curve.
headlights.
Yes. So they can measure that light curve, and it's studying in an area that is 400 times larger than the Kepler mission.
Whew. Kepler was a good chunk. Kepler
was a good chunk. So TESS is taking it to a new level, and as of November 18th of 2021.
Oh, okay. You can do it. The planet count. You can do a planet count.
Yeah.
Do it.
Okay.
Yes.
Let's do it.
TESS has 172 confirmed exoplanets, whilst 4,704 candidate planets are still awaiting confirmation or rejection.
Do we know in total the exoplanet count?
I don't know the total exoplanet count.
It's probably around 4,000.
But this is just what, I think it's around 4,000. But this is just what Tess herself has done.
So Tess could double that.
Oh, yeah.
I mean, it could.
Yeah.
I mean, there's got to be a planet for each star.
4,576.
Yeah. So Tess could ultimately double that. And did you guys hear about the? I don't know who it was, but there was an exoplanet discovered. I'm going to put that in quotes. Discovered in another galaxy. It's the first exoplanet discovered in another galaxy. The problem is that it can't be confirmed because. They have to wait 80 years for it.
Oh shit!
For it to come back around.
And they need 3 times.
Well,
to confirm
but not only
that,
the uncertainties are so big that they can't say on what day 80 years from now, and so so it can't be confirmed.
Wow.
And so it'll always be a candidate. But for the first time,
amazing.
An exoplanet in another galaxy was discovered.
The planet that never was.
Yep.
Or could be.
Like Pluto.
All right,
go ahead.
Visible light. So we got Tess and probably the currently active in space, most famous, most prolific, one of the best telescopes, the most best telescope that we've ever launched up there, the Hubble Space Telescope. And basically, my notes for Hubble are, do we even need notes? It's the Hubble Space Telescope.
It has revolutionized.
Here's just some of the discoveries. Again, some of the discoveries.
These are the highlights.
From Hubble. What Hubble has contributed to our knowledge of the universe.
Mouse pads.
Age of the universe, expansion of the universe, shows that black holes are probably common to the centers of all galaxies, extending visible wavelength images, Hubble Deep Field, Hubble Ultra Deep Field, Extreme Deep Field images, mass and size of the Milky Way. By the way, the Milky Way weighs approximately 1.5 trillion solar units and has a radius of 129,000 light years.
How many of Skittles is that?
So many fucking Skittles.
It is 42 galactic Hubble Skittle units.
Other discoveries made with Hubble data include protoplanetary disks, otherwise known as proplets, in the Orion Nebula, evidence for the presence of extrasolar planets around sun-like stars, and the optical counterparts of the still mysterious gamma-ray bursts.
Wow, and let's break some of this shit down, though.
Okay, all right.
Like with the expansion of the universe, it's not just, hey
guys,
we got the Hubble number. We got the Hubble concept. We figured that shit out. No, it was, there's this thing called dark energy that's making the universe accelerate as it expands. This was something that was not known of.
Like,
how is that possible? I love it.
Do you guys not see this?
Yeah, it's Hubble.
It's dark energy. You can't see it.
There, and all right, so prior to this podcast, we watched a series of things about James Webb on YouTube, and in one of them they were talking about Hubble. Mm-hmm. And they just mentioned that it was that Roman telescope.
Nancy Grace Roman. Yeah, we're gonna get into that. We're gonna briefly mention it. Briefly.
Right,
so you can continue.
What I'm saying is that they mentioned that Hubble is end of life, and it was this Uncle Fester looking dude, and I was like, shut your mouth. It's gonna live forever, but we all know that it's not. And I'm like. When it finally passes,
don't say.
No. We're gonna have part of these special.
It's gonna be. Oh yeah,
his 111th birthday.
We're gonna have a big party. We're gonna invite everybody, like all of you, to join us for this podcast. Oh wow.
Hold the Davison.
It's just a couple.
You got
drops.
it on my iPad.
So anyway.
So we're gonna have a big party. But let's hope that party never comes for. If it does, it's a very, very long time.
Yes, agreed.
That is.
You could do it, Hubble.
That's my telescope, as if I had some sort of thing in this.
Real baby boy.
I'm a baby boy. I birthed it. But
that's painful.
Yeah,
it's painful, Mike.
Yeah, it was. And there was no epidural either. Painful, but anyway.
It's a baby space telescope. Wow.
You had to burp it a few times before God was crying.
I'm good at burping. I'm good at burping babies. I can burp those babies. But anyway, so it has discovered so many things.
Oh, my mom wants to know how it passes away. Does it just decay or turn off?
So you kind of yes and no. So what's going to happen, of course, is the batteries will eventually fail and then the instruments will stop working. But then the ultimate death of Hubble will be a planned entrance back into the atmosphere.
So it's going to have a Viking funeral in the atmosphere?
in the Indian Ocean.
Yep.
Everything in it will be destroyed in the atmosphere except for its mirror.
That's going to go in the Smithsonian.
It's going to go in the bottom of the ocean.
It's going to go in the bottom of the ocean.
Get that
then
shit.
you got to find it.
No, you
They'll find it.
No, because that's the area where they deorbit satellites, so it's a bunch of
They'll
bad
find
shit,
it. They can find the
radioactive stuff
Titanic.
that
They're
you
going to
don't
find
want.
that shit.
You don't want to go in the area though, 'cause it's dangerous.
Are you gonna have,
No,
instead of a swamp thing, is it going to be like the ocean thing
The
down
Hubble
there?
thing?
Godzilla,
Yeah, that's where Godzilla comes from.
That's where, okay.
Bikini Atoll, Indian Ocean,
All right.
satellite death yard.
So, Hubble Space Telescope. Iconic, classic. But there's another type of space telescope out there that you wouldn't really think about. It's a particle detection satellite.
Ooh,
Particle
I like
detection.
those.
Is it still on the space station, or is this elsewhere?
This is called the Interstellar Boundary Explorer, otherwise known as IBEX.
IBEX.
Oh, IBEX.
There's a planetarium show about IBEX. Yep.
That's an initialism.
So it basically uses energetic neutral atoms to image the interaction region between the solar system and interstellar space.
What does that mean, Liz?
That means it basically is measuring like the sun's influence on space and where those boundaries are between the influence of the sun and deep space, interstellar space.
Well done.
Yeah.
Well done.
Well, is that okay? All right. Thank you. All right. So results so far. Initial data revealed a previously unpredicted, very narrow ribbon that is 2 to 3 times brighter than anything else in the sky.
Oh, nice.
And initial interpretation suggests that the interstellar environment has far more influence on structuring the heliosphere than anyone previously believed. But it's unknown what's causing that ribbon itself. Currently.
Oh, okay.
Okay, so
IBEX has been up there for a while, hasn't it?
yeah, I think
did
so.
It
I
say
don't
when
know.
it launched?
No, I didn't write that down. But it's been up there for a bit. It then continued to detect neutral atoms from outside the solar system, which were found to differ in composition to the sun.
Oh.
Which is fun, which is interesting. It also discovered that the heliosphere has no bow shock.
Oh. Bow shot.
Bow shock.
It is spelled bow.
Bow. Bow shock.
Listen, I can't ever fault people for saying words wrong because you're sort of reading it. You just haven't heard them out loud. So I can never.
Right? Okay. Bow shock. I guess I should.
I wasn't faulting
as
her.
like
I
as like
get
a
that.
ship's bow, I
Right,
guess, as the sun ship moves through space.
Yeah.
So there's no bow shock, and it measured its speed relative to the local interstellar medium, so just the local space area, as 23.2 kilometers per second, which is 52,000 miles per hour.
Woo! Holla at us.
Which is
coming to the high.
Those speeds equate to 25% less pressure on the sun's heliosphere than previously thought. So it's basically not going fast enough to create that bow shock.
That's interesting.
That they expected to be there.
That is really interesting.
Yeah.
Okay. All right.
Which is cool. And then in July 2013, its results revealed a 4-lobed tail on the solar system's heliosphere.
Ooh, a 4-lobed tail.
4-lobed tail.
All right, I'm gonna look that up.
Yeah.
What is that? Okay.
I don't know, but it's interesting.
Did they say what caused that?
It's like the
Nope.
Vulpix of the solar system.
Mm-mm.
Interesting.
Yeah.
Okay.
So look at that. So we have telescopes in space measuring gamma rays, X-rays, visible light, and particles, and our sun's influence on deep space and vice versa. Like, that is amazing.
It really is like an amazing time to be alive to experience all this. I mean, Galileo would have never envisioned this.
Right, but I feel this is a conversation for the hangover.
Yes.
Are you
Continue.
stopping me?
No, I'm agreeing.
So we always say
but-
this is the most.
You can end with the Descartes quote.
Ooh,
Okay,
nice.
well, no, but I want to just,
And then
I'm just going to highlight that real
and then
fast.
we need to talk about that as well.
All right.
And then we got
So really quick
Yeah.
about the so there's always saying this is the best time in astronomy to be alive, but then also is it? Because
No.
you think like William Herschel, for example, figuring out what is that weird splotchy spot, and Galileo's like, hey, what's going on here? And Copernicus is like, wait a minute.
And you know what is amazing? All right, so William Herschel maps it out.
Yeah.
And that view of the universe continues until the Great Debate. We actually had a debate.
Fucking love the Great
of
Debate.
William Herschel's map that started with William Herschel just counting stars.
You can join with us for the hangovers to talk about the Great Debate.
Oh my
We're going to talk about all kinds of things in the hangover. Apparently,
Okay, all right.
This is gonna be
the
good.
hangover
All right.
is going to last about 4 hours.
All right, so now coming soon to a space location near you.
Bum, bum.
These are the space telescopes that are coming. Of course, obviously, the fucking James Webb Space Telescope,
The
which
JWST, the John Wick Space Telescope.
is going to be the successor. Well, Hubble's still alive, but, it's this next step up from, the Xbox Series X.
And it's gonna work,
fucking
guys.
Hubble Space Telescope.
It's going to work. It's going to launch. It's going to be
It's
great.
going to be fine.
We're going to be happy.
December 22nd as of now.
And on just so everybody knows, on Christmas Day, things are going to be happening. So don't open presents. Don't open any presents.
We have to unwrap a James Webb.
No.
We have to unwrap a James Webb.
We're
That
opening
is the
presents.
most important thing.
We're opening
There will be
presents.
no present opening.
None. None of it.
We will sit around a tree. I don't know, pick a state, Oregon, for example, and we'll just
He knows
watch.
This is
Hubble.
crazy.
And,
All right.
and instead of telling the story of
Watch
the Red-Nosed
James Webb.
Rainbow, we'll tell the story.
Rainbow?
Oh my God.
Reindeer?
Reindeer, yes. We'll tell the story of the Ariane 5 with that launched the James Webb.
Oh my God.
All right.
Yeah.
Coming soon to a space location near you. James Webb Space Telescope. The IXP, Imaging X-ray Polarimetry Explorer. Polarimetry Explorer. It's going to study exotic astronomical objects and permit mapping the magnetic fields of black holes, neutron stars, pulsars, supernova remnants, magnetars, quasars, and active galactic nuclei.
Hell yeah. Keep going.
Sphere-X, spectrophotometer for the history of the universe, epoch of reionization, and ICE's Explorer. Holy shit,
Keep going. There's
guys.
fucking more.
Come
There's
on.
fucking more.
Come on. It's a near-infrared space observatory that will perform an all-sky survey to measure the near-infrared spectra of approximately 450 million galaxies.
Woo.
Woo! The Nancy Grace Roman Telescope, formerly the Wide Field Infrared Survey Telescope. The science objectives are to
Be awesome.
address cutting-edge questions in cosmology and exoplanet research, answering basic questions about dark energy, completing a census of exoplanets to help answer new questions about the potential for life in the universe.
Get it.
Damn.
Then we have the Survey Telescope. Oh, no.
Who?
No, I'm sorry. Then we have Athena.
There you go.
Advanced Telescope for High Energy Astrophysics. It's an X-ray observatory mission to address the hot and energetic universe scientific
energetic
theme
universes.
that revolves around two
God.
fundamental questions in astrophysics. How does ordinary matter assemble into the large-scale
do that, dude.
scale structures? And how do black holes grow and shape the universe?
I missed everything of this.
Because it's hot and
No.
energetic.
Don't because Brandon will run with it.
And finally, the 2020 Astrophysics Decade Survey. Oh, wait.
So
is
this
not
already
Telescope?
came out.
Oh.
So the Decadal Survey, make as quick as you can. It comes out every 10 years since the Decadal Survey. And it's supposed to guide astronomy for the next 10, 20 years of instruments, of scientific discovery. So this just came out like 2 weeks ago. And so it's just suggesting to Congress, to NASA, to the scientific field, these are the big things we feel should get done. Past things have been the James Webb, the Nancy Grace, the Hubble have all been Decadal Survey items, Perseverance, things like that. And so usually what the first couple of items, they get funded and they get made. So this is a big deal when it comes out because the next 10, 15 years, we're going to be following this lead.
So you want to be on top. You want to be
You want to be in top couple, yeah. So for example, the first top couple. So they've been watching.
Give me that iPad.
Give me the notes. So the James Webb has always been far delayed and way over budget. So
It started in 1996.
that's when the idea came out. Like, hey, what about this?
Still.
And then it was chosen like in 2000s. Oh, maybe in 2011 it'd be launched. Maybe in 2016 it'd be launched. Now it's December of 2021. But regardless, so
it will be launched.
Yes, they want to shy away from these mega flagships of James Webb just because of these issues. So they want to have a fleet of mid-sized telescopes, for example.
Okay.
So mid-size is about 1.5 billion per telescope.
Oh, God.
But this is like in $20-30 as well, so it's not nearly as much.
Or it's a lot more.
In 2030?
Inflation? I don't know how economics works. Never mind. Don't even listen to me.
Just go with what Brandon said.
Okay.
It would be less costly,
Okay.
especially because one of the top items is for NASA and the scientific community to develop and mature technology, so we have more advanced technology for considerably less cost.
I guess my cell phone is cost less than the Apollo 11 mission.
Yeah.
So.
But they do want a couple of big telescopes. They want one 6-meter Super Hubble. A big Super Hubble.
That's what James Webb is.
Well, James Webb's more in the infrared, so Hubble's happy in the visible
light. Okay, a Super Hubble.
And that'd be about $11 billion for the 2040s.
That's how much the Olympics cost in Russia. $11 billion.
The what?
The Olympics in Russia cost $11 billion.
Yes.
In Sochi.
You can have an Olympics, you can have a fucking Super Hubble.
I will take a fucking Super Hubble.
That is, I was not expecting that
That
bit
is
of
just a nugget of
out.
random information
I was not expecting
that I would use in planetarium shows when talking about the Mars rovers.
Okay.
Oh, that would do. Okay.
Yeah.
And they also won the Cato survey, a 20-foot space telescope to detect biosignatures of Earth-sized exoplanets.
Oh, nice.
Which is cool.
Biosignatures. That means life!
Life finds a way. Yeah. So these will be launched in 2030s and 2040s because they get the idea now. They get approval next couple years.
Oh, I had some launch dates on the one earlier. Like Nancy Grace is 2027. A Sphere X is 2024.
Yeah. So all of these were made in the last Decatur survey.
And Nancy Grace is not named for that.
No, she's the mother of NASA.
No, the mother of Hubble.
Oh, okay, of Hubble?
Yeah.
I thought on the thing it said mother of NASA.
Pretty sure. No.
Not like that she founded NASA, but she was just
also
like a...
not the mother of Edwin Hubble, the mother of the Hubble Space Telescope.
Okay. Nancy Grace Roman, not just...
Yes, not
that fucking...
Not that
overreactive.
Idiot.
But, that's a different note altogether. So, yeah, the Cato survey came out, said, here's some really cool stuff you can do, go do. And NASA's like, fuck yeah.
Nice.
Fuck yeah.
I'm sure that's exactly how they said it, too.
Oh, I'm positive a couple of JPL guys was like, fuck yeah.
On that note, everybody, by taking our sense of sight far beyond the realm of our forebears' imagination, these wonderful instruments, the telescopes, open the way to a deeper and more perfect understanding of the universe.
Rene Descartes, everybody.
And that's this episode of Cosmos with Cosmos Telescopes.
Woo!
Eyes of the Universe.
Oh, please stick around with us.
Stick
we
around.
don't know where we're going. It's going to be so much
Stick
fun.
around for the hangover, but otherwise follow us on all the things at Cosmos with Cosmos on most things and at Drinking Cosmos on Twitter.
Tell your
you
friends.
can find us on Spotify, Anchor.fm, and various other podcast platforms, and of course on the YouTube. So for now, thanks for joining us, and we'll either see you in the hangover or we won't.
But hopefully we will.
But take care, be safe, and
Stay safe.
Thanks for joining us. Bye everyone. Peace
Get
out.
the booster, everybody. Cheers.
Boosted.
Get to the booster.
Boost it up. Bye.
Bye.
Kablam! We're back, everyone. Hey.
All right, 40 years ago.
Oh my God. Well, let's introduce the show first before you get so excited. Welcome to The Hangover with Cosmos.
Hi, everybody.
Eyes on the Universe edition.
Brandon's eyes are on his phone, but
So what I'm doing is I'm comparing the L point in the James Webb Space Telescope to baseball, because somebody on Twitter said I don't understand this. So I'm saying, well, the L points are like the bases. When you're on the base, you're safe. You're not going anywhere. No one can get you out. Mm-hmm. Same thing as the L points.
oh, that's a good analogy.
So yeah,
Or you can, or you can just say, think of it as like in space, no one can hear you scream.
That what?
That has what? That
That's
has
what
nothing
it
to do with it.
You're right, but it's not like baseball.
No one can get to it. It's not baseball. I'm taking baseball out of it.
Except in the James Webb baseball, there are 5 bases.
Yeah.
They're not 4.
Anyway, wow. So, episode on telescopes. That is what the main show episode is on today. And
is Ron saying, like, was it Space Cowboys is thumbs up?
Aliens versus Cowboys? Are you watching
Aliens
versus Cowboys?
Aliens versus Cowboys.
That's what it looks like. But he is a cowboy now because he's in a cowboy state.
Yeah, I'm sorry, dude.
But he seems to be enjoying it, what I've seen on social media. You're doing some good stuff, Ron. I would love to have, like, if I was in high school, have Ron as a teacher.
Oh, yeah.
Amazing.
I just want to live there.
Yeah, and I just want you to play your, like, cigar box guitars all the time.
That's true.
I had a Spanish teacher in 9th grade that played the saw. He would come in and he would play the saw as, like, his, like, class opener and get us all, like, focused, and then he'd go into Spanish stuff.
I think Ron would love to do a theme for us on his cigar box guitars.
Yes.
He completely would. And I'm sure he's thinking about making that for us right now. And he'll get us one sometime early next year.
Yeah, okay.
Ron's a great guy. He's a great guy, everybody.
Pandering for anyway.
No, but in full honesty, he really is a great guy.
Fantastic.
He does some great stuff.
The saw. Yeah, it was. I was about to say his name was Mr. Kepler, but it's not Kepler.
Mr. Kebi Cups.
Mr. Kebi Cups. I started with a K though.
And speaking of Johannes Kepler, there was a really cool moment that happened on Twitter yesterday.
With regarding
Kepler?
Johannes Kepler?
Yeah.
Did he tweet? That would be really cool.
That would be amazing.
Musk made a dumb tweet about how his car is orbiting Mars.
Oh, yeah.
When Jonathan McDowell, who's a great guy, said, well, technically it's not orbiting Mars at all. It's orbiting the sun, and once in a while it comes in close contact with Mars. And somebody responds to McDowell, who works for Harvard, by the way, is this brilliant fucking guy. He goes, who made you, or who died and made you orbital police? And he just responded, Johannes Kepler.
Yes!
Oh!
Yes!
And McDowell is like the fucking guy in the world to watch satellites and where they're orbiting around the Earth right now.
God.
So that was just the greatest comeback of
That's
all time.
beautiful. That is. You know what?
Who died and made you orbital police?
Drink to that.
Johannes Kepler.
Drink. Kepler's laws of planetary motion, by the way, for those of you who need extra information on
Technically it's Newton, but...
Well, who died and made Kepler... Oh, Newton. Oh,
no,
other way around.
All right, so in the main episode...
we don't even know what happened.
If you're watching this and did not listen or watch the main episode, go back and watch it or listen to it on your favorite podcast platform at Cosmos with Cosmos. But Mike got really excited.
Oh, that's right with me.
Mike got really excited when we were talking about black holes and spin rates of black holes and shit.
And multiple event horizons.
And multiple event horizons and all this stuff. So, let's fucking
talk about it for a second.
Let's talk about it, so you can get it out of your system. Because I know it's still in there. I know it's just it's bubbling
it's
under
like
the
happy
surface,
puppy.
And you're like, come on, let's go for a walk.
So the one thing that we always think about with black holes is that point of no return.
Yes.
And that point of no return is actually called the Schwarzschild radius. It's the event horizon. Once you pass that event horizon, you cannot ever come back out. But there's actually for true black holes, because the Schwarzschild solution to Einstein's equations did not there was no spin in the black hole, which is not what you find in nature.
It just made him boring.
Yeah, because it's the easiest solution.
Oh, but then there's the Occam's razor. I don't know why I was thinking ladder, so I did a ladder, a visual. That was me climbing a ladder.
But why?
Well, but when you look at nature, when you look at like things in the universe, you see planets. Mm-hmm. They're spinning.
Yes.
You look at the moon. The moon is spinning. It looks like it's not, but it actually is.
It is.
Everything you look at is spinning.
Yeah.
And
we like to spin around sometimes.
And so black holes should be spinning as well. When you look at neutron stars, they're spinning. They're spinning incredibly fast. Super fast. So black holes should be spinning as well. Uh-huh. And there is a solution to Einstein's equation called the Kerr-Newman solution, which actually incorporates the electrical charge of a black hole, but also its spin rate. And so if you are coming into a black hole...
Don't recommend it.
But if you were...
We don't recommend it.
Just in case.
And that black hole is spinning. All right, hold on. Oh.
It's Jack!
Yeah. Oh, Jack's here! I did not even look at who actually wrote that. I just wrote the.
Jack's just joining us
saw
now.
The comment. Yep.
By the way, we need to plug Ron's. What are we plugging? We're plugging Tardy Terror on YouTube, posted via ITN.
Oh.
For Tardy. Yeah. Okay. Anyway, that's my best. I'm sorry, Ron. That was
Tardy Terror.
I don't know how to plug things. No one watches. Anyway.
That was the worst plug ever.
That was horrible.
That was the worst plug ever. Okay, so now we'll never get Ron. Anyway. So, if you don't pass that Schwarzschild event horizon, you're not going to fall into play. You're still able to escape.
You're fine.
However, if it is rotating, you are going to encounter a first event horizon. And this event horizon is, so as the black hole spins, it actually drags space-time with it. It's called frame dragging.
Oh, it's not called space drag?
No, but that actually
it should be called space drag.
It actually be called space drag, you're right.
Technically, space-time drag.
Well, yeah, but...
Yeah. So if you are in a rocket and the black hole is spinning.
Wrong.
Yes. And you point yourself perpendicular into the spin of the black hole. So if it's going from left to right, you point towards the left.
Okay.
There is a distance that you have to be going the speed of light against the direction of rotation for you to remain motionless. If you go 1 centimeter closer to the black hole, you're going to be dragged around the black hole. You have no choice but to actually move around the black hole.
It seems, just based on this, it seems like most likely you're fucked.
You're fucked. You're fucked. And so that point where you can actually remain motionless, but you have to go to the speed of light to do it, which you can't do.
You can't.
That is the actual first event horizon. Yeah, and actually, if you were to look at it, those event horizons come together at the poles at the top, but then the first event horizon bows out, and then you have these, and it's more elliptoid, elliptical, whereas the Schwarzschild event horizon is spherical. It's a circle. And that area in between is called the ergosphere. And that is where you can dump your trash.
Dumb question.
Actually, that is really good.
That was good.
And you can dump your trash and get your perpetual energy from.
Oh, thanks, Jack. RuPaul judges the quality of your frame drag.
Oh, and by the way, Jack, have you watched the Boulet Brothers? What is it on Shudder?
Fucking
horror drag.
Horror drag film.
Oh my god, what's it called?
I don't know, but it's on Tuesday nights. It's on Shudder.
Oh my god!
And we
freaking
love it.
It's actually really good.
We're gonna have to talk about this later on.
Yeah, it's like horror, filth, drag, and it's real great.
So I walked in not knowing what it was, and I figured it was a Halloween special of some kind of drag show. That's just fine. No, but then I come back next week, and it's the exact same thing, but it's in November.
Yeah,
this is fantastic.
Dracula!
Yes!
God, of course, yes. Why can I even...
God, we love that show.
So good.
Anyway, it is so good.
I love it.
Anyway. What was your question?
What was your question?
Oh, goodness. What was it? So we were talking about the shape of event horizons from a distance and the bow. So the dumb question was the classical view of black holes. Let's say classical means the last 15 years.
Or
in the past
accurate
15 years.
Imaging from Interstellar or...
Kind of, yeah. So you can see the event horizon top and then cut towards the center. Is that what we're talking about? Is that something else?
Wait a minute, what?
So you look
the
at the black hole.
visualizations of black holes.
Look at visualization of black hole.
And then,
that ring. Yeah. That's the accretion disk. So, all right. So when you
because that's the other side.
So in Interstellar, when you're looking at that black hole, you have the ring that cuts around the center of the black hole. That's the actual accretion disk. But then you actually see like it going the brightness above and below. That is actually the accretion disk on the backside.
Okay.
That makes more sense.
God, that and also melts my brain at the same time.
Space and time is warped so much that you can actually see the accretion disk on the backside.
God, I can't. My brain, I can't.
Also, if you're looking at a black hole and you're looking at the accretion disk, and the accretion disk is rotating counterclockwise, so from left to right, the left side should be brighter than the right side. And there's a company there's a company that created a black hole, and I was like, well, it's not technically correct, right?
Okay.
And they were like, what do you mean? And they freaked out for a moment, and I was like, okay, no, it's good. It's good. It's good for what you can do for right now. But
yeah.
Yeah,
it's fine.
Okay.
Anyway. My mom asked if it's dragging time. Does it drag time?
Yeah,
forward?
it drags space and time.
Does
Remember,
it do it forward? Can you time travel fast forward?
Well, no, because remember, as you get closer to a gravitational source, time slows down.
Oh yeah.
And so yeah.
We desperately need Weird Al to cover Bowie's changes, but with I can drag time and time can drag space. We can make this happen. It'd be a whole physics thing with Weird Al.
We'll leave you to
Can you call
PR
him?
with
Call him
Weird
up.
Al.
I'll hit up. Hey man, there's this weird thing called Schwarzschild radius, right?
I feel like you'd be into it.
And so, and that whole that you can dump your trash into a black hole. And get
that's
energy
from the main episode. Everyone, reference to the main episode. Listen to it.
Roger Penrose.
Oh.
Sir Roger Penrose.
It sounds like there would be a sir.
Yeah, Sir Roger Penrose, who was a colleague of Stephen Hawking.
There it is.
And they worked together on quite a few things. He's the one who actually calculated how much energy you can get from a rotating black hole. And what you do basically is you're stealing angular momentum from that black hole.
Oh, fuck that black
hole. So the black hole slows down a little bit.
The black hole.
So the black hole slows down a little bit, and you get energy from it.
Okay,
just like Voyager going around Jupiter.
I'm sorry, but Smeagol's positioning right now with just his eye peeking over your shoulder is real. It's perfect.
So this is one of the reasons why I just absolutely truly love black holes, and they're not black at all. They have a temperature, so they're radiating particles, but
they're hot and energetic.
Don't have Brandon say that. Do not have Brandon say that. They are the simplest and most fascinating things in the universe. You really only need 3 numbers to describe a black hole.
And the
you want me to shut up so bad.
They're the things that make my brain melt the most. No, I love how excited you get, and I learn things, but I don't learn things because I don't understand it, but I kind of understand, but I don't understand it. What was I thinking too hard about the other day?
Eggs?
Was it black holes?
maybe.
I don't know. I just the person that came to mind. I can see Liz thinking really hard about the
You
eggs in
remember
the
what we were
fridge.
talking about?
I can't remember.
Is there gas
But I
in
started
there?
thinking too hard about something to do with space or astronomy, and I was like, I gotta stop. I'm thinking too hard about it. My brain is.
Yeah, I mean, black holes shape they're going to shape the universe in the end.
Mm-hmm.
So,
They shape the future.
It's absolutely amazing.
What telescope was it that we got the first image of a black hole? Or, well, of the... What?
Well,
Event
what
horizon?
colloquium of telescope?
Because it was the big announcement, the first image, direct image
The-
of...
Event horizons.
The event
oh shit! What was that? The
Right.
event? It was the Event Horizon Telescope,
Yeah.
right?
Oh, yeah. So that's a ground-based telescope. So
It's
not
a
even
whole
a
bunch of
space.
telescope.
bunch
Yeah.
of them.
Oh, it's a
It's a consortium.
okay.
Who are you gonna go with?
I
Sorry.
don't know. I
Yeah.
didn't have it yet.
Okay. It's consortium.
I was gonna
So-
say satellite, but then I was like, they're not in space.
I don't understand your mom's question. Is there gas in there?
or just
or just
radiation.
radiation.
Oh, I thought she meant like the gas in here
Oh.
because we're being fucking dumb.
I was thinking gasoline.
Oh no, like
Okay.
gases.
Oh, you mean in the ergosphere? Is that what
Or
we're talking
in the
about?
black hole.
In the black hole.
Into the black hole. All right. So if you're talking about the accretion disk, then it's going to be
It's
plasma. It's plasma.
Oh, it's
not
plasma. It's
I
not.
mean, at this point,
'Cause it's
the
so
accretion
hot?
disk, yeah. So
Wow.
the accretion disk is so hot. So what?
How hot?
I don't even.
It's so hot.
It's so
And
hot. That's
energetic.
all I can say. So the accretion disk is really, you know, we think of this as accretion disk as kind of a solid kind of record player that's kind of
Yeah.
a record that's falling in, but
But
that's
it's
not
not.
how it happens.
Okay.
In the black hole?
We
No,
don't know.
we don't even know.
We don't know what's in the black hole, Mom.
We don't know.
We don't know what exists. Does
So
time and space exist?
All
We don't
of that
know.
matter, all of that
It's a single mathematical
everything
point.
is in what we call a singularity. And anytime you hear singularity in physics, that means we don't know what that is.
Like dark matter,
Like,
dark
yeah,
energy. It's
exactly.
a thing that's there, but we
a
don't
placeholder.
exactly know. We can't see it. We don't exactly
So-
know what it is.
Yeah, so singularity, the singularity of a black hole is, in current understanding, is infinite density. It's infinite density, infinite mass, with in a size that is less than a point, right? And so that can't happen. That's impossible. And so we need new physics to actually understand
And new physics. It's a
New
type of-
physics.
new physics. So I really want
That
to know.
could be a band name, New Physics. That would be like a 80s revamp band, New Physics. I don't know.
New physics. So hot right now.
No, accretion disks are so high.
Accretion
right now.
disc.
So we think of accretion disks as records,
Yeah, it's a hipster record
as a
player.
solid-
an accretion disc.
as a solid object that's
It's
just
hipster.
kind of. But that's not what happens. And so basically, think of it as like rings, and they rub against each other. And so the inner ring will heat up, and that makes the outer ring expand out a little bit. And so it's this weird kind of pulsating dance as these things fall in, as these objects fall into the black hole, right?
Cool.
That sounds like it could be another birds and bees talk for the scientific-minded child.
Okay.
Okay, I'm with you. I'm following you.
yeah?
I got you.
Okay,
All right.
all
You're
right.
kind of rubbing in together.
Okay,
All right.
yeah.
Yeah. Good,
All right.
yeah. It's the hot energetic black holes. You know, they just.
You're not allowed to say that, dude. You ruined it.
Well,
You ruined
or
it
did I
in
make
the
it
main
better?
episode. So and so they heat up.
Yeah.
It heats up as it falls
Uh-huh.
in, and they emit X-rays, and that's why X-rays are the death scream of anything falling into a black hole.
X-ray death scream.
Yep.
You know what? Maybe adding X-ray onto it. X-ray death scream.
All right. So apparently, inside the singularity is a koala mosh pit.
With an 80-year-old DJ
That
named Hilda,
is
it could be.
That is the slowest mosh pit of all time. There's like.
This is even too fast. What I'm moving right now.
But lots of square poops.
So is this like the
Smells like
like
Teen Spirit
the
in
people
there.
that were in the original mosh pits of Black Flag 40 years ago when Damage was released? Is this their mosh pit now?
Nice. Yeah, they can bring that back. Yeah, that's
Yeah.
What, I'll do it. You know,
Check out the main episode for that reference, everyone.
I-
At Cosmos of Cosmos.
We're talking to the people
yes,
who were...
and I'm plugging, just in case there are more in the future.
Love the optimism.
Black flag, pivotal to me.
Why do you have black bars
on
your arm?
I need like a
barred for life, man.
Pantera tattoo
Barred for life.
to compensate, but I don't really want a Pantera tattoo. But anyway,
God, what would I don't know.
I don't know, some fucking...
Oh, who would you get?
That's what I was trying to think.
Smiths.
It would just be like Beethoven's face.
Oh, yeah.
The Smiths?
Smiths?
I never really got into the Smiths.
It seems like
He's not depressed enough to do the Smiths.
Well, that's
Though,
true.
I hide it well as well.
Hipster now.
The Smiths were fucking awesome. Yeah, I do love the Smiths. Meat is Murder. Great album.
Meat is delicious at the same time.
But a great album.
All
Great
right.
album.
All right, so we got black holes that you were super excited about to talk about in this Hangover. What you were saving some for the Hangover too? That was at the end of the episode.
Oh, that's right. So the question that was, or the comment that was made is, this is like the best time for astronomy to be alive.
Oh, okay.
yeah.
When in fact there are many other segments of
Yeah.
astronomy where there are groundbreaking discoveries not all the time, but
I think what I said was an amazing time. Well, all right, what I meant was it's an amazing time to be alive for astronomy. Because in 100 years it's going to be even better.
We hope.
Oh.
And then 100 years ago, we had another big moment in astronomy that was what best one to be alive during, the Great Debate.
The Great
No, the
Debate!
Great Debate!
Look at that transition!
You found it. You were searching, though,
That
for what it was.
That wasn't the original intent, but now we're
Okay.
here. This is what we're going to do. So 100 years ago, there was a debate amongst the astronomy field as to whether the Milky Way galaxy, that big band we see in the sky, is the entire
Yes.
all-encompassing universe.
No.
Or if island universes exist.
Oh, yeah.
We're looking at little tiny blurry nebulae off in distance.
Yeah.
I think they could be a cluster of stars, they could be things of gas, or the entirely other galaxies out there. Mike has something to say.
Well, no, I was going to say for those who've not, were not in the original podcast, why don't you talk about Herschel and his contribution to the Great Debate?
So William Herschel and Caroline Herschel, brother and sister duo.
Oh, they're brother and sister?
Yeah.
I don't know why I thought they were husband and wife.
William would get so involved with his work that he would forget to eat for like days at a time. So Caroline, besides also making numerous charts and graphs and scientific discoveries of her own,
Also fed him?
constantly gave him sandwiches. Yes, constantly made them sandwiches.
Look at us.
Really?
Women
Yeah.
got to take care of the
so
men
cool.
all
Also
the time.
bringing him like blankets and sweaters and things,
God.
because he's outside in the English winter.
Your gender would just die without us.
Immediately. Sandwich.
You don't bring me sandwiches or blankets.
I'm sorry, you
No.
slaving away in an observatory night after night looking for
I
new
slave
discoveries of the
away.
universe?
Making drinks.
I do something.
But
I
in any
contribute
case,
somehow.
In any case, with these observations, the two drew this map of the known universe, and this map is really cool. It's to me it looks cool because I know what it represents. It's as if somebody dropped a bucket of water on the ground and it drew a shape, and just kind of nonsensical shape. But that's what it looks like. It really does look like a nonsensical
Well,
shape.
I mean, the Milky Way in the sky looks like a splat.
Yeah, so it's like a big splat they were drawing, and each point represents a star that they were seeing with the big fancy telescopes. But at the time, this was the greatest observing of the universe.
Here's my question. How do you, because, okay, first of all, as we mentioned in the first episode, these telescopes at the time, you don't have the technology where they can just, like, move themselves to keep track with the Earth. They have to move them manually. Night after night, how do you know what star you've already mapped out
Just like
versus...
somebody in this room, they had, honestly, had the photographic memory.
That's me. I made that claim earlier.
So he was actually
It's not true.
He was
but
actually
It's
to remember
pretty
these
true.
insanely small magnitude stars and remember the positioning in location to other stars.
Brandon held up the number 7 in the first episode.
Oh shit!
I did. I did.
Damn it!
And that's the same thing as seeing 20,000 stars and remembering their positions.
Wow, I would not be able to pay attention to that. I would get lost so fast. I wouldn't remember.
No,
what I
it's so
looked at.
easy to do.
I mean, I
'cause
guess
even-
there are markers, but
Right, but even with like my telescope, for example, you can just quickly zoom around the sky, and it's just an ocean of specks.
Yeah.
And there's just no way to differentiate them
Yeah.
unless you're apparently William Herschel.
yeah, apparently.
And he made all those maps. So he made the all-encompassing map of the universe that lasts for like 100+ years until this great debate happened.
Wow.
Oh, we're going to test his photographic memory, by the way.
Oh my god, I already tested it.
Nope.
God.
All right, look at it.
Oh my god.
No, wait. I
didn't even look at it. I can't
you read
read
the quote earlier today by Descartes?
I can't.
Do you remember?
I can't. It's not like that. It's got to be larger image things.
Nope. That's not what you said.
Oh my god.
What is...
and he was positioned like this, and that's how he showed it.
What is the fourth word?
I don't even know. Oh my god, I don't have that good of a photographic memory.
Apple.
I don't even remember what the quote was.
Photographic memory?
I have to be able to picture... I can't picture just words on a paper. I have to picture, like, the scene in which it's happening. Oh, I didn't even know what to look at there.
Well, the quote's right there.
Oh
All right, so photographic memory
This is the best hangout ever.
Oh, Jesus.
Photographic memory is that, well, you can take a photograph of it in your mind.
Okay, well, whatever my memory is,
it's like
I can remember scenes. I can remember scenes.
Okay, what is the fourth word in the quote?
Isn't remembering scenes just called memory?
Oh my god. I can remember scenes for anyway, whatever.
Sense is the word.
Oh my god.
We're gonna stop making fun of Liz here in a moment.
You're
this is why I'm good at directions. It's because I can just picture what it looked like when we were in the area.
Okay. Anyway, continue.
Sure. So you had two camps in the scientific community in the early 1900s. One camp was that, Herschel's view of the Milky Way is the entire universe, and the other view that all these new nebulae that we've discovered are in fact island universes as well, and encompass entirely other Milky Ways. So this was the great debate. Are we all that is, or is there more out there? And they actually traveled. I forgot their names. Was it Harlow Shapley and Curtis?
Harlow. Wasn't it? Oh, no, it was Curtis and Shapley.
Yeah, Curtis and Shapley. Yeah, so
Curtis and Harlow?
Curtis
Shapley.
Harlow. He said Harlow Shapley's name.
Yeah,
Harlow
Shapley.
First name.
It's Harlow Shapley.
Yeah.
All right, so Curtis, yeah, all right.
So they traveled around to like 7 different locations around the country and debated each other whether or not the Milky Way is the entire universe or if there's more. So this was framed as the great debates in the scientific community.
Haven't they learned anything from like Galileo and?
Whenever you think,
of course, it's not.
Whenever you think you have reached,
all-encompassing.
Yeah, whenever you think you had reached our best understanding and this is the biggest we're going to be, there's another step beyond that. Like we're at that right now with We Are the Universe. That's it. There may be more universes.
Multiverses, yeah.
And then it may be like
so total sense.
The Bag of Marbles and Men in Black, and it's just the whole thing.
I hope it's that.
So where did they come down on
this?
They came down on this with a guy named Edwin Hubble.
Oh.
He was using, I believe this was the 100-inch Hooker telescope down in California. And right? Is that
or
right?
Mount Wilson? No.
Wait a minute. All right, who did you say?
Hooker telescope.
Oh, the Hooker telescope? Oh,
with
Hubble.
Or was it Wilson? Oh, I don't know. Don't listen to me. I don't know.
In any case, whatever telescope Hubble was using,
Hubble's the guy, though.
He saw another galaxy.
He's not
out
a telescope
there.
yet, everyone.
No.
Spoilers.
He did discover another galaxy out there and proved that this is too far away to be within our galaxy. Was it Andromeda?
It was Andromeda.
Andromeda, yeah. He showed this was too far away to be inside our own galaxy and proved that...
but one day, we will be together.
Indeed.
Us and Andromeda.
But he also proved that aspects of each one of them, each one of their arguments was correct.
Yeah.
Because one of them used that the globular clusters were at the center, centered on the Milky Way, and that was correct. But the other one said, no, we're not. The Milky Way is not the center of the universe. And so
Hubble comes in, just blows all our minds, saying, turns out we're not the center, guys. We're not all there is. There's more stuff out there. And he goes one step further and goes, all those things out there are going away from us.
Oh,
the universe is getting bigger. Which then he could step back and say, wait a minute. If the universe is getting bigger, if we take a step back to yesterday, to the day before, to many days before, they'll get closer and closer and closer together into a singular point.
But Hubble did not come up with that.
Not really, no. There's another guy out there.
But
Lemaire
was on the way.
He was
on the way. It was kind of that's a deductive process of reasoning that if something's expanding now, then clearly it was smaller in the past.
However, though, he did prove that Einstein was wrong on one part of his general relativity equation.
Said, go fuck yourself, Einstein.
Yeah, and so that was
Einstein.
The cosmological constant, which
Einstein said was his greatest blunder.
Greatest blunder ever. Turns out
it was not a blunder.
Not wrong. Not wrong.
Math checks out.
Yeah. So he had put it in because Einstein believed in a static universe.
Right, which is fascinating because going back through time, so many other astronomers and philosophers believed in the static perfect heavens, if you will.
Well, they reached the edge of their understanding at the time, and so they invoke like a
Right, but
God,
even with but
thing.
Einstein did the exact same thing.
Yeah.
Yes, he wasn't invoking a God complex.
Well, he was
'cause God
invoking,
doesn't roll dice.
yeah,
He
but
wasn't-
he was
yeah.
invoking like a, you know, a other.
Yeah, but it's just funny to think that even Einstein did the same thing. All the astronomers wrote this. Everything's perfect.
Yeah.
because it's
So-
human. He was human, and that's a human thing to
can't
do.
prove that.
Once you get to that limit, you go, well, it must be a higher power. You know,
Well,
like
But he didn't say it was a higher power.
No, he didn't think it was a higher power. He looked at the universe.
He just thought mathematically it makes
And-
sense.
It looked like the universe was unchanging, and so he
time
thought
scales, man, time scales.
well, yeah, but at the time, so he thought that there was something that was keeping it static, and so he quickly understood that his equations would mean a universe that would collapse in on itself. But when you
big
look at
crunch.
the universe, and so quickly the universe would not exist, right? And so we wouldn't be here. And so he's not invoking a god so much as, hey, we've been around for however long it is, and that there's got to be a cosmological constant which makes it static, right?
Mm-hmm.
And so so that's why he put it in there. And well, you can get your phone.
Is your phone vibrating?
Oh, there it is. Okay,
Oh
yeah,
my
my
God.
mom
And
did text
so,
me.
so Hubble finds that the universe is expanding, and so that's why Einstein says his greatest blunder. It was Lemaitre a few years later, who was a Catholic priest, by the way. He was a monk, who came up with the first iteration of the Big Bang Theory, which, of course, all the Christian people now reject.
And of course, the Big Bang was named in jest, thinking, I forgot the scientist who named it that, but he was joking. Huh, so they think it was some kind of Big Bang that started the universe?
Oh,
being
yeah.
condescending, and they go, oh, that's a great name
Yeah,
for it.
sure.
Yeah.
Oh God, who
Except
was it?
no bang.
Yeah,
no
it was
no
actually-
bang
it was
was
a big,
involved.
It was a big
big
name at the
name.
time.
No
yeah.
bang was involved in the making of this universe.
It's probably Curtis.
No, it wasn't. It wasn't that. It was a British guy. He was champion of the steady state, which interestingly enough said the universe was expanding, but as it expanded, it would pop out these little, I don't know, matter.
So here's an activity for anybody at home, all ages activity. Get a balloon, take a Sharpie, and just do a lot of dots all over that balloon, and then blow up the balloon, and that's the universe expanding.
Yeah,
And all those dots are galaxies, all moving away from one another, and circle one of them, and that could be the Milky Way. And basically, I mean, they're all kind of at the center, because there really is no kind of center.
So make all the dots in black, circle one in purple, and then blow it up, and you'll notice that all the galaxies, all the other dots move away from it uniformly. But then circle another one, say in red, and then blow it up a little bit more, and you'll notice that all the galaxies, all the dots move away from it uniformly as well.
And
Homogeneously.
And you know what really blows my mind? Is that the universe is, of course, expanding, but it's not expanding into anything. It's creating itself as it goes. And it's expanding.
Stop! I can't think too hard about it. I can't.
Like you think of this Big Bang as this dot floating in this ethereal blackness, but there was no blackness around that dot. The dot was everything.
No, it's too far. I can't.
And so it's not so much a bang as just a vast expansion.
It's breaking my mind.
Of itself.
This is what
It's
my
an
mind breaks.
expansion of space and time.
Yeah, this is where my mind breaks, because it's like, but what?
Oh, we can break it more.
What? Because I'm a visual person, so I can't visualize it, so that my brain breaks.
No, I get that. And
And it's the most amazing thing ever.
Yeah.
Because in our world, as you blow up the balloon, it is
three-dimensional word.
It is expanding in this space that is the room that we are in.
where you are at. But
Yeah.
it's expanding into nothingness
and so
but nothing doesn't
creating
exist.
everything. I know! I know! There is no nothing.
So in astronomy class that I took a long time ago, that question was actually asked by this guy who's probably no longer with us and was probably one of the worst lab instructors I ever had.
Oh.
But he said that the Greeks called it Ultima Thule.
Oh, that's right.
And so that is what the universe is expanding
Sounds like a Marvel villain.
It's
It
like the
really
promised
does.
land, I think it
It
was.
really does.
No, Mom, how high is up? It's infinite.
There is no up.
There is no up. It's
like the
relative.
it's like the Matrix.
relative to your gravitational
There is
existence.
no spoon.
Yeah, so we define the universe as, everything.
Mm-hmm.
So galaxies, stars.
But it's nothing and everything all at once.
Well, yeah.
Well, it may not be everything.
But it could be nothing.
But it's most likely, no, it's not nothing.
Is it anything?
Yeah, because we're here.
It's like a bad Seinfeld episode.
Yeah, because we're here. It's not nothing.
Who's on
We
first?
exist. Well, okay, no,
What's
let's bring in
on
Abbott and Costello. Yeah, but then you introduce the idea of multiverses, and so what are these other brains hanging out into? And
Pinky.
oh yeah,
Hang out with Pinky.
trying to take over the world. They should do it so that he's trying to take over the universe. So
I mean, he can take over the rest of the universe and Earth's big. Well, that could be difficult.
yeah, when you think about like an expanding universe, it really does. It really does break your mind, break your brain. How did it start?
Before.
How is it going to end? This and it's accelerating, which implies it's just going to go forever.
And that there are galaxies out there we'll never know about because they're too far away.
And then, but all the stars are eventually going to burn out, and there's going to be nothing.
Life is meaningless.
In everything, but there's not nothing, and it's just.
Yeah. So think about this.
I'm going to quote Nietzsche next.
Oh, okay, go ahead.
Oh, I said next. I can do it.
Oh, all right. I mean, think about this. So right now, we look out into the universe. We can see trillions, billions, maybe trillions of galaxies that are out there. Eventually, all of those stars and these other galaxies are going to, fade away. But also, as the universe expands, they're going to get so far away from us. Are you bored?
No.
that we're not going to see them anymore. That the universe is expanding so fast that those galaxies, the light, will never reach us. And eventually,
take it home.
And eventually, we're going to think, like Herschel thought, that this is the only island universe in the entire universe.
And they'll be right.
This is it. The Milky Way. That's all. But there's going to be one star that's going to have a planet going around it. And let's just assume, for sake of argument, that star has a planet that has life on it. They're going to eventually, and that star is the last star that fades away.
It's the last unicorn.
It is the last unicorn in the universe. They're going to think that this is the only star in the entire universe.
And they'll think, well, they take care of this planet and then go to destroy it.
Okay.
Meanwhile, the universe is
You're just projecting
filled.
humanity onto this fictional planet.
Meanwhile,
a real planet.
An eventual planet.
Meanwhile, the universe is filled with these cinders that represent the death of stars and represent the death of galaxies.
Star cinders.
Star cinders,
my
yes.
God.
That this civilization does not even know about.
Yeah.
That they don't realize that here at the end of all things. You gotta take a drink.
I don't have. Do I have any liquid left in that? No. In the lady?
What?
No.
Here.
Horrifying beauty.
Here at the end of all things, don't have to take another drink. That they were a member of a universal community that they did not even know about.
Wow.
What if? Now, bear with me here. What if in these billions or trillions of years from now, these galaxies...
Definitely trillions of years, yeah.
These galaxies become so far away, but there's still a society that has invented wormholes, and they can jump between galaxies.
They can make their own wormholes?
Let's say they can.
All right.
And they can jump between galaxies even though they can't see them anymore.
Interesting thing about wormholes.
It's fascinating.
Kip Thorne, Nobel laureate.
Which is a great name, by the way.
It is.
Second to Rip Torn.
I was just thinking about him.
Second to Rip Torn.
Kip and Rip, they're brothers.
I was thinking both of them earlier today, actually, for different reasons.
Were you really?
Well, because the black hole is number one, and because I'm in the black the other. So, yeah.
So, Kip Thorne, he won a Nobel Prize for LIGO, which is responsible for the gravitational waves.
Black
by
holes
the way,
bumping in the night.
Don't call it gravity waves. It's not what it is. Gravitational waves. But anyway, he is just phenomenal. That's not the word I want.
He's neat.
Oh God, the word is not coming to me. He's an expert in the general theory of relativity.
Okay.
And how to solve the equations of general theory of relativity.
Mm-hmm. More so than Einstein?
Well, we've had a century.
Okay, that's
We've had a century.
Fair.
And you do stand on the shoulders of giants. And so...
It's poor giants.
So he did look at wormholes. Him and Hawking and Penrose and others, they looked at wormholes, and he found that the only way that you can have a stable wormhole. So I'm sorry, Deep Space Nine.
Well, okay. Let's do this, and then we'll get into Deep Space Nine physics.
You need what is called exotic material to actually hold up. To make
I like what? Define exotic for me, please.
Exotic material is basically a material that you're not finding in this universe.
We don't know what it is yet.
Nope.
So unless you're beings that have 6 different dimensions to them and may be able to converse between different dimensions and then can create this exotic material.
Shit that doesn't exist.
Like it doesn't exist.
Yeah, okay.
And no matter where...
What if it's ghosts?
There's a great book called The Gods Themselves. We should read that sometime.
No matter where we look in the universe, we do not see this material. But this exotic material would actually hold that wormhole, make it stable, and so that you can pass through it. Basically, what's going to happen is, as soon as you were to enter the wormhole with, say, like a spaceship, normal, everyday material that we experience, that probably was not good.
This is particle board, by the way.
Yeah, but our microphone is attached to it.
It's fine.
And,
It's the hangover.
That wormhole is going to immediately collapse, so it's not stable.
Well, about 200 years ago, we thought going above 40 miles an hour would kill somebody, and then we figured it out. So hey, come on, guys.
Yeah. So who knows what the future is going to bring? But
I just want to know who decided to call it a wormhole, because that doesn't sound fun.
Well, Einstein-Rosenkranz bridge is a little better. It's not as good as wormhole still.
Yeah. It makes sense.
Just call it the Rainbow Bridge, like in Thor. And in
I really like
Viking.
In the movie Contact, when she's going through the wormhole. She doesn't say, I'm going through the wormhole. She goes, it's going through some kind of what looks like an Einstein-Rosenkranz bridge.
Which is the same fucking thing.
No, yeah. It just sounds more sciencey.
Yeah.
Than a fucking wormhole.
Oh, gotta take a break.
Oh, that was a dog bark. Did my iPad just die?
It died.
My iPad just
gotta
died.
take a drink, everybody.
I gotta get our mouse working so I can do our little drink graphic.
All right. Well, we went through a lot just now.
Your mom said we haven't looked everywhere.
Have you looked under the sofa?
We haven't looked everywhere, though. Technically, we haven't looked everywhere.
No, but
it's just
trying.
Yeah.
We're trying. We needed some new physics for this exotic
I'm
material.
sure there's a wormhole. There's a wormhole in the dryer. Doesn't it steal all your socks?
Yeah, where do all those fucking socks go?
All the socks.
I've
never lost.
I am missing something, but I'm not going to say what it is.
I've never lost a sock. What'd you lose?
I think I've maybe... I've lost an undergarment that I can't find anywhere.
I lose socks constantly. And,
really?
Well, I move a lot, but still.
Well.
It's not like I'm dropping socks on the road.
Yeah, but do you lose the socks in the dryer?
They're somewhere between the transition of me putting the socks in my laundry basket and taking them out of the dryer. Somehow they are gone. I used to have like a dozen nice pair of running socks. Now I have like 3. Where have they gone? I don't know.
Have you ever lost a sock here?
Probably.
Oh shit, we got a wormhole here. We got a wormhole.
Well, the dryer, it spins. My mom says it spins.
That's one of the things.
It spins, and it's hot and energetic.
Oh shit. It's a black hole. It's a definition of a black hole.
Dryers are black holes, everyone. We solved it. There are no gnomes.
No.
Only black holes.
Too bad Hawking's not here to see this.
Rolling in his grave. If he could roll.
Oh. Damn.
Too dark?
No,
Too dark?
I love it.
Okay.
No.
It's fine.
You know his daughter listens to this
No,
podcast.
she does not. But was in our planetarium.
Was in our planetarium, yes. Yeah.
Look, if you can't find humor in that kind of shit, then what are we doing here?
I know, Leia.
All right, who's in charge of all this?
Oh,
Where are we going?
am.
What are we
I
doing?
am. Well, did we have any other topics to talk about? We were excited about black holes. We were excited about the Great Debate. And I think we've covered both of those in a show that was based on telescopes.
You know what? I like Saturn's rings. Let's talk about those for a while. So, in between the rings, there are these gaps called Cassini divisions, right? And those are made by a couple of reasons. You have a resonance between...
Shut up. Get out of here. Go back.
And
Go back on assignment.
Let's not forget Enceladus with its
God.
with its plumes and everything.
That's my ponytail.
And then
All right. Anyway, thanks everyone. I think
responsible for
this has been a great. More dog barks. I don't know what's happening outside. More dog barks just happening, other than the dog barking in this room.
What dog barking in this room? What? Wow.
Anyway.
Already took my drink, so...
I know, this is a little delayed, because I gotta manually do it, because my iPad died. I didn't charge enough. Thank you all for joining us. This has been The Hangover with Cosmos from telescopes...
Wings, right? We're doing wings.
Some telescopes, through black holes, through fucking, wormholes, and just exotic shit. Follow us on all the things at Cosmos with Cosmos. At Drinking Cosmos on Twitter. And we'll
Jack
see
and Maria say goodbye.
We'll see you next time. When's the next episode?
It's in 2 weeks.
In 2 weeks. We'll see you again with asteroids. How do we get them to not kill us?
Yes, that's it right there.
Asteroid redirect mission.
Asteroid redirect missions. We'll see you then. Thanks for joining us.
Cheers, everybody.
Cheers, everyone. Peace out. We love all of you. Every single one of you. With all of our hearts.
I know half was what I should like. Less than half is what you deserve.
On that note.
Oh, shit, we gotta take a drink.
Peace out.
At least I can take a drink.
We're done. We're out. We're gone.